This video is to go over the titration lab calculations for the titration you guys did with the acid and the base. So first and foremost, first calculation. Well, you filled out when you did the titration, you did at least 3 trials where you recorded the initial volume of the acid, then the final volume, the initial volume of the base, and then the final volume of the base. So your data table is going to look a little different than mine. And by the way, I made up this data. It's totally fake. But just to go through the calculations, you'll do whatever you see. So if your numbers don't match my numbers, it kind of doesn't mean anything. So let's see here. First and foremost, first thing that I ask you to do is calculate the volume of the acid used in all trials. So what you would do is I'm going to do one of them. I'm going to take 1160. So my final volume, because what I'm going to do is basically do final minus initial value, and that will give me the volume used, just like when I read it in the burette. So I would go 1160 minus, the started at 3.20. Remember, when I do subtraction, when you do subtraction, least number of decimal places, so this is 2 decimal places and 2. So when I do the math, I get 8.40 milliliters. So that would be how much acid I used. That would be the acid that I used in there. I think you guys were supposed to use around 10, but I just made it up, so go with it. Next thing you do, and then in that case you would do it for 3 of them, because if you would do 3 trials, you'd do this 3 times. You get 3 separate values for volume. Next thing you're going to do is you need to find step number 2, or calculation number 2. Calculate the volume of the base used in all trials and show your calculations. It's still going to be the same thing. It's going to be the final minus the initial volume, read right off the burette. So when I go to do it, I'm going to get 13.90 milliliters is where I ended up, and I started at 0.80. So I'm going to put minus 0.80 milliliters right there. Again, the significant figures in this case is going to be based on the, since you're subtracting the least number of decimal places. So when I go do this, I end up with 13.10 milliliters. And then you would do that 3 times. So this would be the first one, do it 2 more times. Next thing it asks me to do is it says determine the moles of acid used in each of the trials. Whenever you need to find moles, all you do is you take molarity times liters. Will always give you moles of anything in a solution. And so in this case, moles of an acid. So what would I do? Well, my molarity, if you look on the instructions for this lab, the molarity of the acid I used was 0.100 molarity. So I would put that right there. And then I would go back to step 1. I would take the first volume, 8.40, and what I'm going to do is convert that to liters. So it's going to be 0.00840. So I'm going to do that. So then what I'm going to do is I'm going to multiply. So I'm actually going to multiply that out. So I'm going to go 0.100. And I'm going to end up with 0.00084 moles of my acid. So now that I have moles of my acid, I would do that 3 times as well, because each of the trials. Next thing, it says write a balanced chemical equation between the reaction between HCl and NaOH. Remember, any neutralization reaction is between an acid and a base, and ultimately what's going to happen is you're going to produce water always and the salt. The salt is just the ionic compound. So H and OH are going to go together. So if you think about it like this, HCl plus NaOH, well, what happened? Well, the H and the OH came together and made water. And then the Na and the Cl came together and I got NaCl. So that's what I ended up with. It says use the mole ratio in the balanced chemical equation. This reaction's already balanced. So if you think about it, it's a 1-to-1 ratio. So whatever my moles of my acid are automatically going to be my moles of my base. But it says to show your calculation. So if I was going to do a calculation, I would set up a grid. I would go back here, grab the 0.000840, actually 0.000840 moles of the acid, or HCl, whatever you want to write. And the ratio between this is 1-to-1. So 1 mole of HCl is equal to 1 mole of NaOH. you're basically multiplying and dividing by 1, which shockingly will be 0.000840 moles of NaOH. So I've automatically figured out my unknown. That's the whole point of a titration, is to take a known concentration to figure out an unknown concentration. So I have 0.00084, and I'm going to do that for each of them. So basically I will end up with the moles of the NaOH. The last thing it asks is, what's the molarity of the base? Show your calculations. Well, remember, molarity is moles of solute over liters of solution. So I have my moles, 0.000840 moles of NaOH. My last step then is to divide by the volume. What was the volume of the base? I go back to my calculation number 2. In that particular one, it was 13.10. So when I come back over here, I'm going to go, whoops, I need it in liters. So I am going to put 0.013, can't remember what it was. 10 liters. So remember, moles over liters, so then I'm going to just go 0.000840 divided by 0.01310, and my molarity comes out to be, now I have 3 significant figures here and 4 there, so I need 3 significant figures in my answer. I'm going to get 0.0641 molarity of NaOH. So that's from the first trial. See how it says in 7, calculate the average molarity of the base? You would do it for the second trial. You would do it for the third trial. Bam, add them all together. Bam, divide by trace. That's Spanish for 3. And then you get the average molarity of your base. Now keep in mind, your numbers aren't going to match my numbers simply because I just made my numbers up. So the numbers you have from your lab will be more accurate. All right? So make sure you get this all done, answer the post-lab questions, and you are good to go. Hope you guys have a good weekend. Ready? Here you go. Little picture for you. All right?